Oh, really?
Yeah.
Sorry.
Are we ready?
Are we ready?
All right, cool. All right, thanks guys for coming in. My name is, well, we'll get to introductions first, but first of all, welcome to the Splunk session. And like I said, we'll get to introductions now. Oh, I thought I had introductions. My name's Jason Conger. Sorry, I thought I had our names up there, but obligatory cover slide for Splunk. My name's Jason Conger. I'm a practice manager at Splunk for the desktop virtualization space, so I'm going to show you a lot of stuff about Splunk and how it applies specifically to desktop virtualization. That's not only that, but I'll show you that today. This is Brandon Schell.
I run the data center group. I don't really, technically I guess I'm a practice manager, but I have several guys that, Jason and Hal, that work for us to build point solutions on top of Splunk. Jason will go through and explain to you exactly how Splunk works, and this will make a lot more sense to you as we go along. I'm here to answer questions, and then later on I'll talk a little bit more about the business side of the house, the vendors that we're working with. If you're a vendor, how we can work with you to get your data into Splunk, or if you have a specific vendor that you would like to get into Splunk, I can help you work on getting that done. Let's go ahead.
All right, so agenda. My part of the agenda is real easy today. I'm really only going to talk about two things. The first thing we're going to talk about is because you probably don't already know, some of you may know, but what the heck is Splunk, right? So you might be in here, it's like, well, Splunk, I've heard the name. What is Splunk? So I'll teach you what Splunk is. And the next thing I want to do is teach you what a Splunk application is. So two things. What's Splunk? What's a Splunk app? So first of all, to understand what Splunk is, just a bit of background about the name because it's relevant. The name Splunk, the company's name, came from the term spelunking. So spelunking is cave exploring, right? So I'm going to go explore underground caves. So spelunking is exploring machine data. This little one sentence right here, that's actually Splunk's mission statement. It's to make machine data accessible, usable, and valuable to everyone. So three things: make machine data accessible, usable, and valuable, not just to IT pros, but to everyone, right? So how do we do that? So before I get into exactly how we deliver it, I want to explain a little bit about what machine data is. So machine data might be a new term. You can think, big data's out there, but what's machine data? So machine data is time series, unstructured data. And it comes from everywhere. So in an IT department or an IT environment, you think about log files, syslog, Windows event logs, log files, timestamp, and something after it. There's no set structure to it. It's unstructured data. It can be anything. And it's time series. Linux and Unix, virtualization, hypervisors, Windows OSs, things from clickstream data, web applications, databases, all these things are producing machine data. And it's really valuable data, but it's just very hard to go and dig through that data, so explore that data. It's very hard. So if you have a problem in your environment, we've all been through this exercise. All right, user calls in or something's going bad at this particular time and point. We can go look at a log file, open it up, and start looking at all the lines during that time period. Sometimes there might be several hundred or 1,000 lines, depending on how big of a range you're looking at, and you're trying to read every little thing. And sometimes the lines are just like a value, comma, value, comma, value, and you have no idea what those actually mean because they don't tell you what they mean unless you have to go look at some manual and say, well, this means that and this means that. You have to go through and figure it out. Now, sometimes you might figure out, I might be verbose enough to where I can say, all right, well, this hypervisor says it was struggling with storage. I'm like, all right, great. Let me go look at my storage vendor's log. Let me try to pull up that log and figure out what's going on. And so you do that. Sometimes there is no log. Sometimes just things happen and it's not written to a log file anywhere, so it may not be persistent anywhere, right? So then that makes your job really hard if it doesn't persist anywhere. And machine data is not limited to IT data. People use Splunk to ingest machine data from things like elevators, SCADA devices on oil rigs. All these things are producing machine data. Machine's data is everywhere. And so the concept behind Splunk, remember, we make machine data accessible, usable, and valuable to everyone. So how do we do it? Well, you have all these things producing data, and they can send the data to what we call a Splunk instance. A Splunk instance is a logical term. It could be a single server. It could be a whole farm of servers. distributed all over the place. But just Splunk, in a logical term, is just a Splunk instance, right? Just keep that in mind, a Splunk instance. So all this machine data goes up to the Splunk instance. Some of it, like syslog, you can say just deliver it there. Sometimes we have to go poll for data, which you can think of as an agent. We call this thing a forwarder, which you'll go grab some information from a particular environment and send this machine data over. Those are the things that are things like that are not persistent. There might be something going on in the network, a storage fabric, something like that. We can go grab data at points in time and send it to Splunk. All of that data comes into the Splunk instance, right? And so now Splunk has all that data, but we're not making it accessible or usable yet. Splunk has to do something with it, right? So to think about what Splunk does, you think about like Google out there is indexing web pages. So all these web pages that are out there in the world, and they have tons and tons of information on it. And when you want to go find that information, you go to Google, you type in what you're looking for, and through Google's algorithm and PageRank and all its smarts, it will direct you to the right place and get you what you need because Google has indexed those pages out there. You have the Google bot that crawls and it indexes stuff, so it knows where to go find what you're looking for. This is what Splunk does. Splunk indexes all this machine data, so when you need to go find something, you go type it in, and Splunk will go out there and look for it for you and help you get to what you're looking for. Now, I mentioned at the beginning that machine data is unstructured data, which means there's no upfront schema. When you think about an Oracle database or a SQL database, you have something called a schema. And a schema is simply just a definition of what your data looks like, right? It's tables, it's views, it's fields in the table, there's relationships between the tables. That's a schema. The problem when it comes to doing a schema is you have to know the answer to the question, you have to know what question you're going to ask before you ever ask it. Meaning, when I'm designing a schema, I say, all right, I'm going to design this table that has this field and it's going to be this kind of data type, and I'm really have a rigid structure on the data, which means I have in mind the question I'm going to ask of it later. As this schema gets populated with data, I have in mind what question I'm going to ask. But by this very nature, machine data is unstructured. There is no standard for machine data. It's a timestamp and stuff after it, and you can't plan for that because something new comes in. There's no standard to say you must follow this format. It's all unstructured. So you can't really have a database. But because you can't have a database, you don't have to know the question you're going to ask before you ask it. And the thing about machine data is it's just data. And different people are going to ask different questions of that data. So an IT pro might ask, I need to know really stuff about performance. What's going on in my environment? Are things healthy? Somebody that's more interested in the business, they might know, all right, what is my capacity? What's my current capacity? Where am I? What I'm going to look like 3 months from now so I can go through a procurement cycle if I need to. I need to know all this stuff. A security person wants to see abnormal things in very normal data. So here's how things are supposed to look. Find things that are outliers. What's wrong? All the machine data, all the answers are there in the machine data. You just have different questions of the machine data. So Splunk allows you to ask those questions, any kind of question you have. There's no custom connectors with Splunk, meaning a lot of products, if you're going and grabbing data, you have to massage that data to get it into the schema. So you're saying, I'm going to go collect data from this. I'm going to transform it to fit my schema. Well, you don't have anything like that with Splunk. In fact, Splunk doesn't even know what the data looks like before it ever gets there. It's just sitting there waiting for data. It doesn't know it has no idea what you're going to send it, ever. And then, of course, there's no relational database management system. The reason that's important is because when you start talking about machine data, you talk about massive amounts of data. And when you're in RDMS, you have scalability issues. When you get this much data every hour, minute, second, day, then an RDMS is going to start to struggle with performance and scale. All right? So I like demos. I like showing it. 2 slides were already in a demo. Let's check out what we got. So what I want to show you now is what Splunk looks like. Right? So you go and you install Splunk And this is your default user experience out of the box. I install it, yay, it can install on, I'm running it on a Mac, it can install on Windows, Linux, HPUX, all these kind of things. You can install Splunk, it's just software. The hardware requirements are very, very minimum depending on what you want to do, but you just install it. You go download it, install it. You can install it on your Windows laptop if you want to. I'm installing it on my MacBook here. And when you go and it says, all right, you finished, go to this URL. There's the URL it gives you up there. This one happens to be the IP address here. Go here, and boom, this is what you get. And you're like, I don't know what to do here, right? I don't know. It has this search bar, and it has these things that are going on, but I really don't know what this means. So let me tell you what it means. The first thing we do, whenever machine data comes in, Splunk tags it with 3 things. The first thing is what host sent it to me. So it could be the machine itself, it could be like some kind of device, it's something had to produce that data, so it tags it with a host. That's what produced the data. And that's down here. So host right here, these are showing me all the hosts that are sending me data. The other thing is the source of the data. Where did the data come from? Did it come from a log file? Is it a syslog message? What is it? Here's the source. And the last thing is kind of a metadata piece. It's a source type. So it's like, what type of data is this? So you can have some predefined source types, but this is just what Splunk figures out of the box, is what is the type of data that's coming in. So out of the box, we have some data coming in, and this is what we get. So, and then you're like, what do I do? Well, I mentioned Google indexes web pages. Splunk indexes machine data, so we have a search bar. That's your default user experience out of the box. And also I mentioned that all machine data is time series data, so you have a time picker over here. So you can do all kinds of relative times, or you do custom times. You pick what time range of data you want to look at. So if if this is my default user experience, I'm just kind of doing some troubleshooting or something like that, you can use this search bar to do that. So what I want to do here is there's all kinds of data you can see. It's hard to see from the back of the room, but this is Hyper-V. This is some running process. There's some VMware data in here. There's all kinds of data. Zen Server, VMware, Hyper-V, XenApp, XenDesktop, all this kind of data is in here. But for sake of time and brevity, I'm going to just focus on a use case for XenApp right now. So we have all this other kind of data in here, and I'll say I really just am interested in XenApp. So what I'm doing here is I'm typing the word index equals XenApp. Remember, Splunk indexes data, and generally we store different types of data in different indexes. You don't have to. It's kind of a best practice because you can have retention policies on Splunk and all this. So I'm just going to say I want to look at just my XenApp data. So I just type index equals XenApp. Also, what you'll notice is as I type, we have this IntelliSense type thing going on. So as you start to type a command, it's going to show you, as you're typing, what are some relevant things here. And it'll show you, here's some autocomplete stuff, and here's some documentation about what you're typing here. So as you type it. So what I'm going to do here is press enter on index equals XenApp, and I'll get some stuff back, and I'm just like, still don't know what I'm looking at. So I'll tell you what I'm looking at, and it'll make some more sense. So what we're looking at here is data from a XenApp environment. And so this, every kind of, see the little drop-down arrows? Every one of these lines right here, that's called an event. You could think of it as one line in a log file. This happens to be generated not from a log file, but actually from a PowerShell script. So a script runs. Whatever the output of that script was on the screen ends up in Splunk. So this is really cool. So if you don't have a log file, you don't have something that's persistent, you could say, I want to write this script, and whatever would have ended up on the screen, put that in Splunk, and it will do that. So if this happens to be PowerShell, you could do it in C script if you want a VB script. Whatever ends up on the screen, standard out, is what ends up in the Splunk index. So what this PowerShell script is doing, you can't really see it, but this is a XenApp ICA session. So this is all the virtual channels that are going on in somebody's session. So it has your input bandwidth, the output bandwidth, your different virtual channels for LPT, for your video, all this kind of stuff is in this event. And same thing for this one and all that. Over here, remember I mentioned those 3 things that Splunk indexes all the time. You have a host, a source, and a source type. We can see the different types of data that we have here. There's a session process and a session and a server and an application and all that kind of stuff. That starts to feel more like what I'm used to in my environment. But also under this, you'll see some things that say these are interesting fields that Splunk found in your data. And it does all of this in real time. So what's happening is I'm narrowing down my scope, and Splunk is looking at all this text right here, all of this text, and it's looking to see what looks interesting, meaning fields in all this text. And it says I found 12 interesting fields, meaning I looked at here, parsed out field names, and an interesting field.
Actually, I found 121. It just showed you 12.
Right, the reason that only 12 are interesting is because 12 show up in more than 50% of the results here. If I were to narrow my source type to just something else, I'll have more interesting fields because I'll have less data set. I'll have more interesting fields because more fields are going to show up in more than 50% of the data. And all of this is being done in real time. We call this late binding. So again, Splunk doesn't know what all this was going to look like ahead of time. We just said, go put that in Splunk.
And all these fields, all the fields that you see extracted, that happens like when he did search, when he did index equals Zen app and press enter, that's when it looked at the data, it started pulling the data in, it looked at the data and said, these are fields that I think are interesting. And then it populates that bar. So this happens at search time. The reason why that's important is this goes back to the we don't have to worry about a schema or a structure, because all of that's done at search. It's not done prior.
Yep. And so at this point, we have data in, and we've made the machine data accessible. So it's accessible. We can get to it, right? So remember our mission statement, make machine data accessible, usable, and valuable to everyone. It's accessible now. We haven't delivered on the other two on making it usable or valuable yet, but it's accessible. We can get to it. So let's explore how we can make it usable and valuable. So like I said, I'm really just, through my scenario, I want to know some information about my application usage in my environment. So I'm going to go over here and let me look at the types of data, and one of them over here is, it says, what this says is hard to see from the screen. I know it says XenApp:65:application. So it's a XenApp:65 application. So I click on that, and that narrows my scope down to just application data within my XenApp index. So now my scope of all the data I'm looking at has reduced. So now instead of 12 interesting fields, I have 50 interesting fields. Again, that's because I see 50 fields that show up in more than 50% of the data. In all actuality, still I have, well, most of the fields are interesting, but there's 64 fields. So there's some extra fields in here that don't show up a whole lot, but 50 show up a whole lot in this. And again, you'll see all these fields, again, in real time, like Brandon said. All of these things are getting extracted in real time. Again, this is not very usable yet, right? So this is where the power of Splunk comes in. So far, I haven't really done anything profound. I just said, here's an index, and I clicked on something that says just narrow the scope down. All I've done so far is just show me this data, show me that data. Now we want to do something with the data. This is where the Splunk search language comes into play. There is a search language in Splunk, just like there's hidden tidbits in Google, you can do kind of cool things on the search bar. There's things you can do in the search bar with Splunk. And so just like any kind of command line processing utility, you have the pipe character. It means I'm going to take everything I have so far and I'm going to pipe it into something else to do something. All right, so take this set of data I defined so far, I'm going to pipe it into a command now to tell it to do something interesting. So the command I'm going to do is I want to do some statistics on the command. I'm going to say stats, which is short for statistics. And I just want to do a count by browser name. So browser name in XenApp, when you publish an application, there's an application name and then there's something called a browser name. A browser name is a unique name for the application. So I just want to get a count of all my applications by browser name. So now this is becoming more usable. Instead of seeing all that raw data behind it, what I'm seeing now is something more usable. So there's all these commands and how often they've been used within that time range up there. So here, this App Center has just been used once. This desktop's been used a couple of times. There's this other desktop's been used 3 times. So we're getting a count of all our applications within that data set. This is just standard Splunk stuff. But that's interesting to look at. But what's even more interesting to look at is charts, because people like charts, right? Especially your manager. So what we do here is, let me make a pie chart out of this. What I do here is this makes the data even more usable, right? So looking at all that text, what I've done here is all I did is change from stats up there. I said, instead of stats count by browser name, do a chart count by browser name. So now I can visually see what is getting used in my environment. What's the most used, what's the least used, all this. So this makes it a lot more usable. So the thing that, we did all this, but the thing that where the power of Splunk really comes in is I don't want to have to tell somebody, if I want to give this to my manager, I don't want to have to tell him, hey, go to Splunk, type this in, and you'll get what you want, right? Not interested, not going to happen. So what we can do as a good administrator is I say, I want to create a dashboard out of this so he can go see it whenever he wants. So I click this little button that says create, and I'm going to create a dashboard panel out of this. So I click that, and it's going to step me through this little wizard. And I'm going to call it this BriForum. So I say, I'm going to call it this, this search BriForum. It's going to save this search that I did there called BriForum. And then the next thing it's going to do is say, I want to create a dashboard. A dashboard had multiple panels, but I got to create a dashboard. It's a container for panels. So I'll call it this dashboard apps. Okay. And then I click next. And finally, I'm going to define the dashboard panel. A dashboard's a container for multiple panels. But now I created a brand new dashboard, and I'm going to put this panel on the dashboard. And I'll just call it, BriForum apps. I'll call that is the name of the thing. So we'll click finish. And Splunk is going and creating that dashboard for me. So now I can go tell whoever wants to see this information, here's a URL. I can give them a link, whatever. And there's no search language involved. It's just, boom, there's your pretty pie chart. And of course, everything, these are all done with JS charts. So it works on iPad, it's HTML5 stuff. So it all works. So here is a nice, pretty chart. I could decide later, I don't want it to be a pie chart. I want it to be a bar chart. So there's all visual commands for doing all this. So I turn on edit, and I say, I want to edit the visualization on this thing. And I'll go click on that. And I'll say, instead of pie, I want bar. I can do that. Save that out. And wait a second. Thinking. There's my bar chart. So now I have a bar chart instead of a pie chart. So we can see visually over here the number of apps are even more. So turn my edit mode off, and I have, I can mouse over. All the mouse over stuff is automatically in here, as well as drill down. I can drill down into the different things as well. And really, to produce this, you saw, we did it in real time. It's really quick, and you can create really nice dashboards for people to give some usability to your data, right? So we made our data accessible first by bringing it all in, doing our indexing. Now we make it usable to show you different ways. So usable by going through and doing the statistics commands, or looking for anomalies in the environment, or right here we're doing some charts to be able to visualize our data. So that makes it a lot more usable. So let's go through the same exercise again, going to our search command. And maybe I want to do now something. I'll start out narrowing down our scope. Index equals in that. And now, instead of applications, say I'm really interested in sessions. So on source type over here, I really want to see some stuff about sessions. What's going on with sessions in my environment? And so what I've done now is here's every session that is happening in my environment over the past 60 minutes. And the end goal here is I want to get a unique count of users per server. So what I'm going to do here now is I just want to dedupe. It does exactly what you would think, remove the duplicates. I want to dedupe on the username and the server name. So what this does now is only gives me the unique users per server. Again, we're just narrowing down our scope here. It's not very usable, but now we get to do some cool stuff on the visualization. I want to do a stats count by server name. And what this does, can you guess what this is going to do? this is going to give me the unique count of users by server name. Real quick and easy. It's like your manager wants to know how many users I'm getting per server. Well, there you go. Boom. Every server and how many unique users you're getting within any kind of time range. So any kind of time range will pick up here. If you want to see that nice and pretty, maybe you want to see it over time. What am I doing in, as far as the past 24 hours visually? So I can change my time range over here. Instead of 60 minutes, go to 24 hours. And then I'll do what's called a time chart. And what this is it's going to say, instead of a regular chart where I just did a bar chart or a pie chart or this, it's going to give me a time scale on the bottom, and it's going to show me the values for each thing over a period of time. So I press enter here. Turn on the visualization here. And here is a line chart that shows me from 12 p.m., 4 p.m. Of course, this is this is on the time zone of where the sessions were created, which is not here. This is in the U.S. But you can see exactly what you expect as people are getting to work and they're logging on, and then the data came on at the end. So I was like, this is a really interesting thing as well. It would be cool to add this to that dashboard I created earlier. Easy. I want to this way. I'll create this dashboard panel. We go through the same exercise. And this time, instead of doing it on a new dashboard, I'll just say I want to reuse that existing dashboard that I did, that BriForum dashboard. Oh, I didn't share the dashboard. Let me back up. There's a concept in Splunk called, there's a concept for authorization. And what happens is you can say, I want this dashboard to be seen by only me right now, which I don't want anybody else because maybe I'm working on it. I don't want anybody else. Then when you get done, you can say, hey, I want to share this out. So I'll come over here to my BriForum dashboard.
I thought you called the dashboard apps and the panel was right.
Oh, is that what I did? That's probably right, because that's probably it right there. We'll go look at, this is, I'm jumping ahead of myself. This is what an app looks like in the background. It's XML. And you're exactly right, Tim. Thank you. I did call it apps. So this is what the dashboard, the dashboard is just creating XML behind the scenes. So this is what it looks like. The opening XML says dashboard. The label is apps. It has the search name that we created earlier. Here's a title. And here's all these options for the chart. This is very, very simple to do this. So yes, you are correct, Tim. And I probably did share that out. So let's see if I did that.
It was still marked as private, I think.
Was it?
Yeah.
No, it was set to app. All right, so sessions.
Yeah, so the benefit of that is if you want to create an app, for example, you have a specific group and you only want them to see certain dashboards, you can create dashboards and then isolate it to only that app. So you don't have a whole bunch of dashboards popping up. Like if I have a Zen app dashboard, I don't want to see a bunch of Zen desktop forms and stuff, or dashboards pop up.
All right, so there I just added that dashboard panel to the apps dashboard. There is visualization editing right here. Maybe I don't want this side by side. I can drag and drop, turn it off, and I have a side-by-side dashboard. And just like earlier, everything is sizable, so I can bring that down to be the same size. So all of this is just built-in functionality with Splunk. So these are cool visualizations. This is more usable. Where things start to become valuable is when Splunk can tell you things that are going on in your environment. So last time I'm going to do this exercise before we move on. I'm going to do one more search, one more visualization, and this one is going to be more around some capacity planning. So say that I know how many users my farm supports, and I want to have some kind of visualization on it, whether I'm in range or falling out of range or something like that. So again, I'll go through the same exercise, index equals inapp, to narrow my scope. This time, what I'm going to do is, I'll look at sessions because that's going to tell me unique sessions going on in the environment. And then this time I'm going to do a little bit different. I'm going to do a stats. And I'm going to do just the shorthand. A DC means distinct count username, meaning all these distinct username as, I'm just going to label it as num users. And what this is going to do is give me a single value back. So that number of users, it's hard to see back there, is 258. That's just a single value. But again, I said I wanted to visualize this in a meaningful way. So on these single values, I have some formatting options. I wanted to do this radial gauge thing. And what this does is it gives me this cool little radial gauge. By default, it pegs out at 100. So that's why you see the little needle moving. And our actual number is 258. But I'm going to show you what you can do here. I'll go ahead and save this and create another dashboard panel out of this. I'm going to say farm users. And I'll use that exact same, that dashboard we created earlier, the apps dashboard. And I will finish this. Click on apps. And that's our dashboard. And so now our new panel is down here at the bottom. It always goes at the bottom. And so again, our count is 258 right here. It maxes out at 100 because that's what it is by default. But because we have all these visualizations, all this on-screen visualization editing, I can just go over here and edit. And I want to edit the visualization. And on this one, I can have these color ranges. So it's set to automatic, which pegs out at 100, but I can set it to manual. And I can say from 0 to 100 users is good. And I can say up to 200 users is that. And then up to maybe 300 users is that. Or I'll go 250 just for visualization. Actually, we're at 258. I'll go 260. Save that. And now our visualization gives us a green area, yellow, and a red, and our needle's not pegging all that. But what if our max was 250? If we did change that to 250, it would go right back to the pegging in the needle and all this. So instead of 260, 250. And of course, you have to figure all that your capacity planning out using some load testing. But there, we're at 250. It's not quite pegging because it's not way past, but you see you are on the red line there. So this gives you a visualization to quickly see how am I doing, what's my capacity. So now we've made our data accessible, usable, and valuable at this point.
And all of these can be real time, by the way. They
Yes.
can be real time or historic based on however you want to do it. And with a little bit of extra magic, you can actually have time pickers for each one of them, or a time picker for the whole thing. So by default, it would do 60 minutes, but if you wanted to see 24 hours, you wouldn't have to go do edit, edit, edit. You could actually have a master time switcher that would do the whole thing.
Yep, absolutely. All right, so that concludes my demo and explanation of what Splunk actually is. I'm not going to go into apps just yet because before I go into apps, we've talked, we kind of show you what Splunk did. But before I go into apps, I want to give you a little bit of an overview about the architecture of Splunk and what makes Splunk different. So the architecture of Splunk, I said Splunk instance, I said that's a logical thing. It could be one machine for a very small environment. So right here we have, here's a single machine. Now we're talking about physical pieces at this point. So here's a physical machine, one physical machine that does everything. And then you have these, what we call forwarders. They're optional because if you have syslog, you can just send syslog directly to Splunk, or you can have, Splunk go reach out and grab information, or you can put what we call forwarders. You can think of a forwarder as an agent, meaning I'm going to install this forwarder on something and have it send data to Splunk. And actually, forwarders are really dumb. They don't do anything. You install a forwarder, nothing happens. So, for instance, on a Windows, if you install a forwarder on a Windows box, it installs a service account, but it doesn't do anything. It just sits there. What you have to do is you have to actually tell the forwarder what to do. You say, I want to go grab this log file. I want you to look at this performance metric. I want you to look at these processes. You have to tell the forwarder what to do before it actually does anything. The reason that's important is because people always ask, all right, if I go put this agent on my machine, what's the overhead? It depends on what you're telling the agent to do. By default, the overhead is nothing. It doesn't do anything. Then you have to tell it what to do. Most of the time, what we're doing, especially in the VDI environments, we are collecting information that is already there. So either via log files like a Windows log, perfmon, or we have these scripts that go and run against different APIs that will grab information. And the cool thing about it is Splunk doesn't create any additional write IOPS. And that's important when you get into shared storage environments, because what happens is Splunk runs a script, the output of that script goes over the wire to the Splunk index, and never writes it local with an asterisk. Meaning the asterisk is if it tries to send the data over to a Splunk index and it can't reach it, it will store it local until it can reach it, but that's the exception to the rule and doesn't happen very often. So that's important. A lot of other products, they will have some kind of local database that it's writing to and then upload that payload on a scheduled basis. We don't do that with Splunk, so we're not creating write IOPS. Everything else is already there. We're just reading the log files or reading the performance counters and sending that over the wire. We're not writing it local. That's also important is as the data comes into Splunk, we're not aggregating the data. We're not rolling the data up. So the granularity that you have today is the same granularity that you have a year from now. We don't care how much data you store. You can store 10 years of data if you want at very granular levels if you want. We don't care. We don't even charge on how much you store. Splunk is licensed on how much comes in versus how much you store. We don't care. So at the very base level, and what I have here is a single Splunk instance running on a laptop right there, and then we have forwarders sending data to that. The next thing, when people start to branch out and we say, all right, I want to go into a lot of data, you can start to split things out. So what we have here at the top, we call that a Splunk search head. That is the web interface that you're seeing. So when I'm showing you and you see me typing in stuff and you see the graphics coming back, that's called a search head. That's your user interface. Then you have this down here, these are your indexers. That's the thing that's doing all the magic, doing all the work. And we can load balance these things out. You can have as many indexers as you want. And the cool thing about it is there's no additional infrastructure requirement to do that. You can think of it as a RAID array with a disk. You say, I want to put 3 disks in. I want to put 5 disks in. And you could lose indexers and it will still give you back your information. It replicates between the indexers and you won't lose data. And like I said, no additional infrastructure requirements. No load balancing hardware, no cluster services, nothing. Just Splunk. You just install Splunk and you go. And then again, here's all the forwarders sending data over to the environment. And this scales very, very, very large to multiple terabytes. We have customers doing multiple terabytes, over 100 terabytes of data every day. To think about this, machine data is text data. It's not binary data, it's text data. 100 terabytes of text data every single day coming into a Splunk infrastructure. Normally that would kill over, it will definitely kill over a relational database, but normally that kill over a system. But the way that Splunk is able to ingest all that, you can bring it all in, but then if you need to go search on multiple terabytes of data that comes in every day.
In real time.
In real time, yes. So either over at this minute or as it's coming in over past 24 hours, whatever, we use something called MapReduce. MapReduce was actually invented by Google, and I think of it as a kind of a multi-threaded process. So if you have a Windows process and it needs to go do some work, it can spawn multiple threads, and those are asynchronous. When they're done, they report back up to the parent process as, hey, I did the work, here it is. That's the same thing that MapReduce does. Whenever I type something, Splunk is going to send that out to multiple places. They're going to do their work, and they're going to return the results back, and Splunk's going to aggregate it all together, which makes it very, very, very fast. This is the same algorithm that Google uses for their search engine. I mentioned, this is kind of hard to see, but this is the architecture we were looking at before, where we have like a search head. You can have multiple search head, multiple indexers, multiple forwarders. The cool thing about it is you can have these things like instances across the globe. So here's a built-out site in New York, another one in Tokyo, another one in London, and you can search across all of them at the same time. So I can say, I don't have to say, all right, let me go and run my search in London. Here's that information. Let me go run the one in Tokyo, and here's that information, and let me try to piece those together. You can have an overarching search that goes over everything. So
Although you could tier it if you wanted to. If you had branch offices and you wanted like a local guy to only see his stuff, you could create a search head for him that would only see his indexers. But you and the corporate could have a search head that hit all the indexers. So you could have tiered views, and back to the whole security, you can say what people can see and what people can't see.
Yep, exactly. Okay, so that's it on what Splunk is.
How much time do we have?
I don't know. It's 3:20. We started it. I don't know what happened. That's it on what Splunk is. 20 minutes.
Okay.
That's it on what Splunk is. So any questions on just Splunk? We call it a platform for machine data. Any questions about that platform before I move on? Okay. Then you got a
Yes.
question.
Can you configure alerting? Yes, you can.
Yeah, so can you configure alerting? So yeah, anything in Splunk is a search. So all those visualizations are search. Alerting is, we set up alerts all the time that just, it's a search. It says, go look for this. And the cool thing about alerting in Splunk, most alerting is like, let me know if the process, the CPU gets above this. You can set up a very smart alert that, only alert me if this and this and this and this happened, and you define that with a search language.
And
Alerts,
it lasts for this long.
yeah, and alerts can be sent via email, of course. They can, you can set up an RSS feed if you want, or you can respond to them with a script, which means what most people do with a scripting, you could take a corrective action. Most people don't have a script take corrective action. Most of the time what they do is they have a script that spawns a ticket in the help desk system. So you can say, if these perfect set of storm things happen, spawn off a help desk ticket that goes into, and they have a record of it and all that kind of stuff. That's what most people use the alerting for, at least the scripted part of it. But the email stuff and all that stuff is in there as well as report, schedule report delivery. So if I just want to have a cool report that gets delivered via email to my boss every Monday, you can do that as well. Okay? So that's it for Splunk as a platform. Now Splunk is proprietary software. You download it. There is a free download for a certain amount of data in a day, but after, and that's 500 megs of data, you can get 500 megs of data perpetually for free. Once you go above that, you start getting into a paid license. That's how we make our money with Splunk. Splunk is a platform. The next thing I talk about is Splunk apps. So the concept of an app is all this stuff that I did with creating a search and visualizations and telling these dumb forwarders what to do. We package all that up together for you in an app. So we'll package up, say, here's a configuration for a XenApp forwarder. Here's a configuration for a VMware forwarder. Here's a configuration for a Cisco UCS. Here's a, for Hyper-V, for NetApp, all these different things. We send you a configuration on how to get the data in. Then we also send you a configuration for all the visualizations. I showed you a little bit on the XML for creating that dashboard. We send you a lot of dashboards that are already done for you out of the box. So day one, if you have this kind of environment, you can get some value out of your data versus having to go and do what I did, because there is a learning curve to doing what I did. I made it look really easy and quick, and that was not very detailed. There's a little bit of a learning curve to that, but it's a pretty quick learning curve on doing things because it's a lot like command line stuff. So to show you what an app looks like, again, we've been doing XenApp stuff, so I'll show you what we packaged up together for a XenApp app. So we come back over here to our Splunk instance, and we have this little drop-down list that says, here's all the apps that are installed here. And I happen to have one installed for XenApp. There's Xen Desktop, there's Hyper-V, there's VMware, there's all kind of apps out there. So here's our XenApp app. And so this is Splunk. You'll see it's branded different. You can do style sheets and graphics and all that kind of stuff. You can make it look pretty. You can put your logo, whatever you want to do. You can do all that stuff. You have a web designer. But all the stuff here, this is just a table. This is a search that produces a table with what we call spark lines, and this, these are some visualizations.
As a matter of fact, there are several SDKs, so you can even get the power of Splunk without even using the search head if you wanted to.
Yeah,
you could build your own app, and we have customers we have vendors that do that where they're using Splunk and you wouldn't even know it.
Yeah, you don't have to use our UI. You can use a Windows app. You can write your own web app. You can integrate all this. It's no problem. Okay, so I'm not going to go over all of this app, but one of the real things that shines with XenApp is the thing that comes to mind is user calls in and something's slow. They call in and say, I'm having pain. I don't know what's going on. And so what we have here is this user experience kind of wizard. And what we do is we say, all right, give me your username, I'll type that in, and I'll select the server that you were on at that point in time, and I can see what's going on. It could have been over the weekend, it could be going on right now in real time, but this is kind of a level 1 help desk type dashboard. So what I'm going to do say we have this user called Dan. Dan calls in and says, I'm having some pain, and I'll list all the servers Dan's been on in the past 24 hours, and we'll say he was on this server right here. I click go, and what we're going to see now is a dynamic dashboard that's going to show me everything that was going on in Dan's session at that time. So we can see the first thing, you kind of think of this as layers. So there's a lot of stuff that makes up a XenApp environment. There's a networking piece that you have to come in. There's the server itself. If that server happens to be virtual, there's a hypervisor layer. If it's using shared storage, there's that layer. There's all the running processes in Windows. All these things contribute to what's going on and impacting Dan. So the first thing we'd see is we kind of do it by layers. Well, the first thing we'll see is like, all right, there's your session stuff. It looks like your ICA session latency is high, so I can drop this thing down here and I'll get a time chart so I can see, in the past 24 hours, this is what your session latency looked like. It's kind of high, but
it's consistent.
Huh?
But it's consistent.
Right, so that's the point, is if you have a lot of jitter in there, then that could be a problem. But RDP, ICA, PC over IP, they're very good at dealing with consistent high. So if it, that's pretty high, but consistently high, it can deal with that. All right, so we'll look farther down the stack. We'll say, here's the host. What's going on the host? We can see here's some processor stuff. It's like 97.52% processor time. That's on average over the past 24 hours. That seems kind of suspect. So I click this little drop-down arrow here, and what I can see is, wow, it's kind of pegged out on this processor on the past 24 hours. That can't be good. So let's see if there's anything farther down the stack on what might be going on. What happened here is Splunk looked for this particular XenApp server in the Hypervisor Index. And if it found it, it will show us stuff about the hypervisor it's running on. So here's the hypervisor, and it's hard to see, but there's a link right there. It found it on a Xen server host, and the host happens to be running at 100% too, on average. I was like, well, that can't be good either. So do the same thing, drop our list down, and we can see over the past 24 hours, wow, that host is pegged out as well. So it looks like we need to go see what's going on in the host. We click this link right here, and that will take us with context over to a different app. Again, just apps are pre-built sets of configurations, and we can see some things going on here. What we see here is a big red box with an X, so that can't be good, right? And it's saying the average vCPU/pCPU 50.17. You're like, well, what does that mean? And you mouse over this little guy right here. This is all just HTML, JavaScript stuff. Anybody can do this, and it defines what that is. So basically, what we're saying, that number right there is saying for every one physical CPU, we have 50.17 virtual CPUs assigned on average to that host. So we are way oversubscribed on VMs on that host. And actually, we see every physical CPU in that host. This happens to have 24 cores, so we can see all the 24 cores going down, and they're all pegged. So we are over-provisioned on this. We need to take some kind of action, either shut some VMs down or do a live migration or something like that. We need to get this particular host off of here. We need to do something here. This is bad, right? So that's what's going on in Dan's session. Kind of do the same exercise just to show you. It's not always hypervisor. We have Bob. Bob calls in. Same thing. I'm having a poor user experience. I need you to tell me why I'm having a poor user experience. So go through the same exercise, Bob. Let's see what's going on in Bob's session. And so same thing. We get his ICA stuff. This time the host, looks pretty good. And that's a little bit high, 43.3. But the disk transfer, man, 152.43. That can't be good. And that's read and write operations. Let's see what's going on here. We're like, wow, the disk is really going all over the place, and it's way high. It should be around here, 50 or less. But we're really high, so that can't be good. So let's scroll on down. Here's the hypervisor that it's running on. This time it's Hyper-V. It's running on a Hyper-V, but things look good here. But this Hyper-V server is using shared storage. It's using a NetApp filer. And our write latency, this top line, is our average write latency over the period. By default, our best practice, this should really be less than 10. It should never really you peg at 10. It should be less than 10 consistently. We're consistently almost 60 milliseconds on the write latency. So we could drill down into our NetApp app. When this app was written, the NetApp app wasn't released. It is now, so there'll be integration just like the Hyper-V stuff and Zen Server stuff. NetApp will as well, so we can drill down into the NetApp app, because we do have an app for NetApp as well. So you can go through and investigate what's going on my shared storage. But now it has this one, hypervisor is in here and everything looks good, but shared storage, bad. So we can go in and figure out what's going on there. And so in a nutshell, this is what an app is for Splunk. It's just a set of configurations and visualizations. Anybody that had Splunk could do this themselves. We just do it for you out of the box, so you get some immediate value. On our website, there's a website called Splunk Base. If you go to Splunk.com, you can go splunkbase.com or you go to splunk.com and see Splunk Base. That's where we keep all the apps. And so apps are written, some are written by Splunk. There's over 320 apps and growing every day. This is where you can go grab the app. There's apps written by Splunk, supported by Splunk there. Then there's community that are uploading their apps as well. So somebody might have found something really cool. It might just be one dashboard in an app. They said, here's something really cool. And they upload it because they want to share with the community. And so there's over 320 apps. Also on Splunk Base, there are, questions and answers. It's a very active user forum on there. So you can go get questions and answers there. There is support with Splunk. But the important thing to remember about almost all Splunk apps is I showed you the dashboard stuff. Apps are open source and they're free. You don't pay extra for the app. So you go to get Zen app, you want to get that, you want to get...
to be clear, Splunk, we don't charge for apps.
Yes.
There are people that actually do charge for apps. They charge for their collectors or something like that. And that's not necessarily bad, but that's not the stuff that we release, specifically in the business development group. All of that stuff is free. We don't charge for it.
Yeah, so you can go and download, like if you want to get that Zen app or the Zen desktop or the Hyper-V, whatever, you can go download that app. The app's free, and it's open source. So if you go look at the source, you'll see the XML, but you also see the searches. So that's a good way to learn how to do the searches as well.
And you can change it.
Yeah, you can change it.
If you want the dashboard, you're like, I like that dashboard, but I wish it did this, or you can kind of deploy the app, and that was the intent. When we created these apps, the intent was not to just give you an app and then, oh, well, all is good. We know everything you need, and this is all you'll ever need. The idea was to give you enough dashboards that it was a lot of value and it was worth investing the time and energy to deploy, but to also give you ideas. So the idea is that you'll get it, you'll look at it, you'll get a lot of value. Then as you have more time and you want to start changing, that you might, like, I don't like the search, I wish it did this, or every environment is different. And anyone that, most people realize that. It's everybody's different. And you can take this app and you can make it your own. When you make it own, there's a different subfolder that this stuff goes into. So if we release a new update, you don't lose all your changes. So there's provisioning for that. Mm-hmm. Are you almost done? Because I want to take the last.
Yeah, the only thing I wanted to mention again is if you go to Splunk.com, free download, you can get that for free. You can even have perpetual for free, like I said, up to 500 megs. So anyway, yeah, I'm done at that point.
So I hope this was valuable. I hope, initially it probably started off a little slow, but we had to build the foundation. And I hope at least you've kind of started the clock going and understanding where this can take you. Sometimes it takes a few times of listening to this or thinking about it, but there's a huge value in what we do, specifically with the apps. We've kind of showed you what he's done with the NetApp and stuff like that, but if you expand that, imagine you have Atlantis, you have all these other companies that start building Splunk apps and allow you to get their data and put it into Splunk. Imagine the association and correlation you could do. You could have a user and be able to find out quickly across the board what's going on with that user, a user-centric view, which is critical, right? I don't want a storage-centric view. I want a user-centric view. On top of that, we showed you, because most of you guys are IT specific, we showed you IT views. But Splunk is really an operational intelligence or business intelligence solution, right? If you do it right, you can get the same dashboards and you can change them just slightly to where they appeal to a CEO or a CMO or a CIO or whoever that is, who your sales guys, each different group has got a different thing that makes sense to them or that's important to them. The fact is that the data is there, right? So if you collect the data, you can make the views. Like the CIO might want to know, how good am I getting enough users on my servers? They're more like, is my stuff being used properly? Am I getting a lot of value out of the resources that I'm providing you? Where the IT guy is more like, I just want to keep the things up. I just want to make sure stuff doesn't break. The help desk just wants to do it very point solution. When a user comes in, they want to solve an immediate problem. Where the IT guy is more like, I want to know what's going on. I want to make sure the environment's stable. Again, the CIO is more wanting to know, capacity planning. When do I need to buy more hardware? When do I need to do this kind of stuff? When is my storage? Is my storage being used properly? Do I have terabytes of unused space? That kind of stuff. Anyway, so the idea and what we're doing specifically in our group is we're working with vendors to expand the data footprint in Splunk so that the value gets to be broader. So that's kind of where we're going. We're also working. So we're working. We have a lot of partners we're working with. I don't know how many of you use F5. We're working with F5. We're working with the NetScaler team, Cloud Gateway team. We're working on a couple of other Citrix teams on getting their data into Splunk. Palo Alto. We're doing a lot of work with Palo Alto. Cisco UCS. A lot of Cisco stuff. We're getting that stuff in. And the idea is anything that's in that stack, I want to get that data because every piece of data you can get, it just makes it easier and better for the IT staff to get a quicker time to resolution. So we have about 10 minutes left. I want to spend some time answering questions or discussing if you have any thoughts. You can ask now. Or you can leave. Whatever. I mean, was this clear? Does everyone understand kind of what's going on? Yes, sir.
What does that look like? You install it on the Hypervisor?
I'm sorry?
What does that look like? Do we install it in Splunk?
So
Repeat
the question was, what does an app look like? So from a Splunk perspective, an app is really just a collection of dashboards and searches that somebody else has kind of done for you. What it looks like in the file system is really just a folder with a, do you want to show them a folder structure real quick?
Yeah.
We can show you. It's just really a folder structure that says, hey, this is where my views are, my XML, this is where my searches go, any kind of configuration, what we call inputs, which basically says, hey, Splunk, this is the data I want you to go collect. Then there's the outputs, which is, hey, Splunk, this is where I want you to put the data. And then we have what we call macros and transforms. And all that stuff is just how you can educate Splunk on what the data looks like, right? So Splunk will do some kind of cursory looks at the data. In our case, the data was it was a key value pair, and Splunk deals with that really well. If you just have like a string and there's not any kind of clear pattern in the data, what you'll have to do is you'll have to create a regular expression and say, hey, when you see this digit, digit, colon, digit, digit, colon, digit, digit, colon, or hexadecimal, right? If it looks like a MAC address, then that's a MAC address, right? If it looks like word/username, that's a username. So you can kind of educate Splunk, and that's in the config files. So that's this is kind of what this is the Splunk app for Zen app, and up there is the folder structure that you see. And then under there is app server, which is where you can do that's where you put your CSS and any kind of data collectors. If you want to ship it with the app, you would put it in there. Under default, so remember when I said, if you want to make changes, you don't want, and we release something, you don't want to have those changes overdone. So what we have is default and local. Those are really just kind of mirrored directories. Local overrides default. So when you make a change, you make a change in local. You never change default. We change default. The idea is that understand if you change something in default and you don't put it in local, the next time we do a release, it's very possible you'll lose your change. Does that make sense? Lookups. So in Splunk, you can do what they call a lookup, which is basically, let's say there's a search, right? And you want to say, this user was on this VDA, right? Which that's kind of a point in time. It's a point in time data. So if you want to be able to look at that in the reverse, you can do with it. You can do a search every hour, every day, or however frequently you want to do it, and you can put that in a CSV. That's called a lookup, and then you can use that association. Actually, a better one is for we use a lookup for Citrix licensing, right? So the API returns a number, which is not useful to most people. So we created a lookup that converts that number into a text value that people would understand, that kind of stuff. And the last is metadata. That's where you kind of security rights, permissions, who's allowed to do what kind of searches. You can hide searches, you can make searches public, that kind of stuff. Good question. Took like almost 10 minutes to answer. Any other questions? Really?
How do you govern the security of who get to see what information?
How do you govern it? So you can do it in the UI or you can do it in the command line. It looks very much like a
What do you
an
repeat the
ACL.
question?
So how do you do the security for like the searches and dashboards and stuff like that? So the easiest way to do it until you get really comfortable with the syntax. So everything you see is really just a config file. And that folder structure, all it is a bunch of config files. The UI is just a way to manage those config files in the UI, right? But once you get like the XML and stuff, once you start getting much more efficient at Splunk, you're going to start bypassing the GUI and just start doing it at a text editor because it's 10 times faster. But up here you can add users, you can add roles. So that's how you say this is a user that can do it, and role is a type of user. So if you have like help desk, like you would create a role called help desk, you would add the users that are in help desk into that role. This can also be Active Directory integrated. So we link the AD so you can do it that way. But specifically, if you go up to manage, over here you have searches, reports, event types, fields, all this kind of stuff. Most of the stuff over here you can ACL, right? So if you go up to a search, and you see permissions, you can change the permissions there. And that will let you change who's allowed to. It can show, that can tell you what apps are allowed to do it, and you can actually even change who and what can do it. Up there is the top one is like keep private, which means that only I can see it since I created it. This app only means as long as they're in the context of the app, they can see the dashboard. And the other one is I don't care, everyone can see it. Okay, another good question. One more. No. Any other ones? Yes. Oh. Yeah, what would you like?
That's our moderator saying we have 5 minutes left.
5 minutes. We got 5 minutes.
Another point that I want to make that sometimes comes up is when we do an app, we collect a lot of stuff, right? And so if you have a system that's collecting information that we're not, say that you have some information in a database, like we can bring in that data as well. We don't have to collect everything and put it in Splunk. So if there's a database, there's a utility called DB Connect that's part of Splunk, and saying, hey, I'm collecting all this data, but I want to bring in more data. I want to augment what I'm doing, showing you here in Splunk. We can reach out to a database, bring that in, same dashboard. It looks as if Splunk got it all inside of Splunk, but it's external, so we can do that as well.
Yeah, you would use that instead of a lookup. So if you wanted to do some kind of query, a good example would be an Active Directory. Like I wanted to do an Active Directory association. You could actually query Active Directory as well, but that you could use that like that.
Yeah, or it can be a
Lookups
database.
don't have to be a CSV. They can be any kind of thing. And
Yeah.
DB Connect is a very
Yeah, it could be a database, it could be a web service. You can bring in other types of data to augment or to complement what Splunk is giving you as well. And then everything's configurable as well. If we're collecting performance metrics and you already have something else collecting performance metrics, you can turn that piece off. So when I talk about forwarders, universal forwarders, we're saying we're collecting all this stuff, including performance, but you already have something like SCOM or something like that collecting performance, you can turn our part off and say, let SCOM do it. That's no problem. So we can do that as well. So everything is totally configurable in Splunk.
So archiving and retention policies.
archiving and retention policies. Those are set up by index. So if you go back to the manage thing, there's a section down there for index. If you go in there, you can change like how long. We actually have 3 states. We have hot, warm, cold, and you can tier those off into different type of storage. So it's actually pretty complex, but in regards. But you have the home path, like where the database is. You can do cold path, thawed path, all that kind of good stuff. You can say the max size, like if you want to make sure, if you don't want to like not fill up your disk, you can say I only want you to do X amount of space. Understand that it's textual data, right? It's all text. It compresses really well. Well, most of the time it compresses really well. So it's like 70, 80, 90%. So it doesn't take as much space as you would think. But you can modify that. You can actually tell it, at this size, roll it over. You can say, either by a month or by size. Again, this is the GUI, so it's not got all the options. If you go in the config file, it's insane how complicated you can make the config.
Also, something to remember on storage retention, anything the operating system can see, we can use for Splunk. And there's different ways you can roll things off. So if you have very high power storage that you want to store this much data on, and then the really historical, say I want to keep 10 years of data, but I don't want to fill up my SAN.
You can even go to tape.
Yeah, you can go to tape. So if the operating system can see tape and can say store it on tape,
your search will be really, really long.
Yeah.
We're waiting for somebody to put that tape in. But
it will work.
It'll work. But so you can do that. So you can archive pretty significant. Any other? Oh, so we'll be at the booth, or one of us will be at the booth most of the time. We have Jason's cards. He's responsible for the apps that y'all saw today. So he has cards up there. Feel free to stop by, get a T-shirt. We love giving away T-shirts. Thank you.